In this video, we want to learn how to draw the Lewis structures of atoms of elements of compounds. Before you begin to draw the Lewis structure of atom of elements, you must have an idea of the periodic table. And from the periodic table, we can get the number of valency electrons that is in every atom of element. And when we talk about valency electron, this is simply the number of electrons an atom of element is willing to share, willing to lose, willing to gain in order to become stable. Stability means having octet or duet configuration. So every atom of element has a valency electron. And to know the valency electron, we need to count the groups of the periodic table. 1, 2, 3, 4, 5, 6. Okay, we need a 1 here. So we have 6, 7, we have 8, or 0. All right, now we're going to put all the elements that from 1 to 20 elements, we need to put it, and excluding that of the transition element. So I have He, which is hydrogen, Has, which is helium, Litho, which is lithium, Bright, which is beryllium, Brain, which is carbon, Can, which is boron, Can, which is carbon, Not, which is nitrogen, Alpha, which is oxygen, Full, which is fluorine, 9, which is neon, Subject, which is sodium, Many, which is magnesium, Art, which is aluminium, Student, which is silicon, Prefer, which is phosphorus, sulfur, and then we have chlorine, then we have argon, then we have potassium, then we have calcium. Anyway, if you want to know how to name the elements without looking at your textbook, we have a video on that. Now, all these elements has in the same group has the same valency electron. So now to draw the Lewis structure of chlorine, what's the valency electron of chlorine? That's the first thing to ask. The valency electron of chlorine is 7. So you're going to draw the Lewis structure in such a way that you will arrange the valency electron of chlorine around the element chlorine. So I'm going to arrange it by putting, I'll distribute it singly before pairing will occur. I have 1, 2, 3, 4. I don't like this. Let me change. All right. 1, 2, 3, 4. All right. Now, is it up to 7? No. So I'm going to put another bond here, another bond here, another bond here. So this is 7. So this is the Lewis structure for chlorine. What of the Lewis structure for nitrogen? Now, for the one of nitrogen, the valence of the electron of nitrogen is 5. So I can put 1 here, 1 here, 1 here, 1 here. And then if I put a 1 here, that makes it 5. What of hydrogen? The valence electron of hydrogen is just 1. So if I put a 1 beside hydrogen, that's the Lewis structure for hydrogen. What of oxygen? I'm going to have oxygen. The Lewis structure for oxygen, what's the valence electron for oxygen? That's 6. So I'm going to be having 1, 2, 3, 4, all right, 5, 6. All right. Now, this is how to write the Lewis structure of elements, except from helium, neon, because already helium is octet in its outermost configuration, so it's stable. Neon is octet in its outermost configuration, so it's stable. But all these other elements, they want to be stable. That's why we have this is known as lone pair electron. This other two is known as unpaired electron. So you can have an exam question that say, how many unpaired electron and how many lone paired electron is in chlorine? Chlorine has 1, 2, 3, 3 lone pair electron and 1 unpaired electron. Nitrogen has 1 lone pair electron and 3 unpaired electron. Hydrogen have no lone pair electron, 1 unpaired electron, 2 lone pair electron, and 2 unpaired electrons. So look for the valency, and you can actually write the Lewis structure for any element you want to write. Now, let's go to a continuation of these elements. Let's get some molecules. Let's say we have hydrogen combining with hydrogen. Hydrogen always needs one more electron to become duet and to become stable. So this electron is shared between these hydrogens. So we're going to be having a structure like this. All right, so this is the Lewis structure for hydrogen. Of course, you can represent the Lewis structure or the electrons with just a bar. All right, and then up next, we want to draw for nitrogen. Now, nitrogen, of course, you have 1, 2, 3, 4, 5. We're going to combine it with another nitrogen. We have 1, 2, 3, 4, 5. Now, notice that we have 3 unpaired electron, 2 lone paired electron. What do you think will happen? The 3 unpaired electron will form triple bond. So you see, nitrogen love to form triple bond. Oxygen and hydrogen love to form single bond. So what will happen here is that there will be the triple bond, all these electrons combine with all these, and then you're going to be having the lone pair on here on it. Now, it has 2 lone pair electrons and a triple bond in it. Now, we can go to the next one. Let's talk about oxygen. And let's say we have oxygen. It has 6 valence electron, 1, 2 unpaired, and then 2 lone pair. So now we have the other oxygen here. All right, so we have 1, 2 unpaired and 2 lone pair. So these 2 unpaired electrons will love to burn together. When they burn together, then we form double bond. That's what we found there. Because 1, 1, 2, 1, 1, 2 will form double bond. Just like this 3 form 3 bond here, these 2 will form double bond. So what I'm going to be having is oxygen. All right. So I'm going to be having the lone pair, lone pair, lone pair, lone pair. So that when I have 4 here, 4 plus 4, that's 8. 4 here, 4 plus 4, that's 8. Okay, let's talk about this one. 6 here, 6 plus 2, that's 8. 6 here, 6 plus 2, that's 8. Every element wants to be stable. For it to be stable, it has to be 2 or it has to be 8. Whatever is 8, whether it is 2, it becomes stable. Any of those is okay for its stability. So let's go to the next one. Can we pick up chlorine? Okay, chlorine, 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 chlorine. So we have chlorine. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we have 1 here, 1 here. So these electrons are going to be shared. All right, they'll be shared. So we have these as the Lewis structure for chlorine. Now, at this junction, I hope you understand what we're doing. So let's go to your compound. Let's say we are talking about carbon dioxide. All right. Now, you are going to count the number of valence electrons in this compound. And let's start off by counting carbon. How many carbon do I have? 1. How many valence electrons? What is the valence electron of carbon? That is, where is it? 4. So 1 times 4, that is 4. What's the valence electron for, how many oxygen do I have first? 2. So 2, what's the valence electron for oxygen? 6. 2 times 6, that is 12. You add up number of electrons, I think this is 16 valence